Hello everyone, welcome to our YouTube channel GKR Soft. In this video, we are going to understand one of the most fundamental concept in AUTOSAR operating system, that is basic task. If you are learning AUTOSAR or working on ECU software, then basic tasks are everywhere. So let's understand them very clearly in this video. First, we can start with what is task in AUTOSAR operating system. A task is a simple unit of execution managed by the operating system. It can run, be suspended, be activated, and it is scheduled based on the priority. There are two type of tasks. One is basic task, another one is extended task. And in this video, we are going to deeply discuss about basic task. Might you have seen that when you are working or creating a RT event, you have to map with the OS task. So event to task mapping basically will be done in the RT level in AUTOSAR. So if you want to understand about RT events or any AUTOSAR related concept, then you can follow our AUTOSAR playlist. What is basic task in classic AUTOSAR operating system? Basic task in AUTOSAR operating system is the simplest type of a task. So a task that cannot wait, cannot block, and cannot use events. It always runs from start to end once it becomes running. A basic task is a task actually runs sequentially, has no wait stage, does not use events, and cannot be stopped in the middle, and only ends when the function finishes or explicitly calls a terminate task or chain task. So what are the basic task possible states we have in AUTOSAR operating system? So the first one is suspended, and this is allowed for basic task. So here basically if the task is not activated, and another state is ready state. So it's also allowed in basic task. That means it's activated and waiting for a CPU. Next one is the running state. This is allowed in basic task and it means it's currently executing. And there is another state called waiting state, but this is not allowed in basic task, meaning it's not allowed for the particular basic task. This is only used in the extended task. What are the key characteristics of basic task? So whether the wait event is allowed in basic task? No. So set event can be used in basic task? Not applicable. So can we block the basic task? No. What is the internal state there? Nothing. And what is the activation thing? It can be activated multiple times. And rescheduling is can be preempted and resumed. And the ending is it will be must end with terminate task. Here, you can see the example for AUTOSAR OS basic task configuration. So first we will see that I have used OS task type as auto. So here, the tool decides whether the basic or extended. But since there is no OS task event is configured here, it automatically becomes a basic task. And there is no wait event configuration, no OS task event reference, tag sharing is false, and OS task uses FE is also equal to false. So this configuration represents periodically activated basic task. Likely, it can be triggered by an alarm every 10 milliseconds. First, we will decode this container step by step. The first one is OS task activation. This is in my example, it is configured as 1. So what is that meaning? Maximum number of activations allowed in queue. So most of the things in the basic task and also the periodic task, we will come up with the task activation is 1. And the next one is task priority. So it will defines the static priority of the task. So higher the number, higher the priority. And priority is actually determines preemption, CPU allocation, and schedulability sequence. And another one is OS task schedule. So here I have configured as full. That means it's fully preemptible. There is another option, none. That means it's a non-preemptive. So this will defines if the task is preemptive or non-preemptive. That means a higher priority task can interrupt this task at any time. And another one is OS task stack sharing. So this is I configured as false. So whether this task shares stack with other tasks or not. That's the meaning of OS task stack sharing. So if it is true, then multiple tasks use the same stack. So it will save RAM, but there is a risk. Then another one is OS stack size. Here I have configured as 8 KB. So this is RAM size allocated for the task stack. So this is particularly for RTE periodic runnable task, communication handler, and timing event task. But this all depends on your architecture. Then another one is OS task type. Here I have configured as auto. So the OS generator decide whether the particular task is basic or extended. So since you don't use events, wait event, task event reference, then automatically this will be considered as a basic task. And another one is OS task uses FPU. That means whether the task uses floating point unit operation. So if it is true, then OS saves and restores FPU register on context switch. How basic tasks are triggered? So for triggering the basic task by calling activate task, basically this will be done by RTE. So if you see in the RTE configuration or rt.c file, then you will come to know what all are the tasks are activated by activate task API. Basically, event based task will be triggered by using activate task API. And another important thing is alarm action. So by using alarm, the basic task will be triggered. And schedule table expiry point. So by using schedule table, we will activate the basic task. And ISR by using interrupt service routine, we can activate a task. And another one is auto start in application mode. For an example, if you have a init task that cannot be activated by any of the other function call, then you can use auto start functionality during your operating system basic task configuration. And here you can see whenever you have a basic task, you can see such a kind of function is generated by your generator. Or whenever you are going to define your task functionality, then you have to use in such a way. So just think about it. Here we have a three runnable entity that is mapped with 10 millisecond task, whichever we created right now. Then in that one, automatically these three functions will get called. Very important thing you have to note it here is every basic task should be terminated. So here I have used the API called terminate task. So the pre-OS rule is nothing about basic task must be terminated by terminate task or chain task API call. So why basic tasks are important now? Why we need to configure a basic task? So whenever in your project, you know about predictable execution. So you know that this call particularly runs for 10 millisecond or 50 millisecond or 100 millisecond. Then in the cases, you can prefer a basic task. And you know that for a particular requirement, you no need to block the particular task. Then you can prefer the basic task. And for a fast scheduling and perfectly fit for periodic and fast response functions. So in these cases, you can prefer the basic task. And here, when to use a basic task? As I mentioned that when your execution is short and no waiting is required and no periodic event or periodic wait for event and code must to run completion quickly, in these cases, we can prefer the basic task. And where not to use a basic task. So you need even waiting. Then in the cases, you shouldn't prefer the basic task. When you need a synchronization or you need a task suspension or you require asynchronous wake up, in these cases extended tasks are preferred. So don't use the basic task for such a cases. So finally, basic task is simple, non-blocking, and run to completion task with no waiting and no events. So to summarize a basic task, it's a fast, efficient, and run to completion task that forms the backbone of AUTOSAR OS scheduling. And it is ideal for periodic function and short computations. So if you found this video useful, please like, share, and subscribe to GKR Soft. Thanks for watching. See you in the next video. Thank you so much.